Some trigonometric equations can be solved by taking square roots, and we'll do this very similarly to how we've solved quadratic equations in the past using square roots. So my first goal should be to get the squared part of the equation isolated, so I'll go ahead and divide by 4. And so I get the equation cosine squared of theta is equal to 1/4. Well, as I said, like we've done with quadratics, let's go ahead now and take the square root of both sides. We'll recall that one of the very, very important key steps to remember when solving with square roots is when you do this, you actually get two possible answers for this side of the equation, a positive and a negative version of that. So that's what we got to make sure that we do for these problems. And then from here, they'll proceed very similarly to how we've done other trigonometric equations. So when I take the square root of a fraction, I just do the square root of the top and bottom separately. So I get plus or minus 1/2. And so at this point then what's kind of interesting is normally we go ahead and we look up the reference angle, the cosine of what angle would get us 1/2, and then we figure out what quadrant we want to draw that in. Well, this time, because we have a plus or minus, really our angle can be in any quadrant. Any of those 4 quadrants would be where our angle would lie. So I guess let's just go ahead and find the reference angle. So looking at my trig chart to find out what angle gets me a cosine of 1/2, I see that that angle is going to be pi over 3. And then, again, that's my reference angle. But then as we just said, because we want to get a positive or a negative version of that answer, really my angle could be in any quadrant, because cosine is positive or negative in one of those 4 quadrants. So if I went through and I found out the actual angle for all those different reference angles depending on what quadrant I'm in, I see that I'd end up with 4 answers for this problem. Pi over 3, 2 pi over 3, 4 pi over 3, and then finally 5 pi over 3, because each of those would get me either a positive or a negative 1/2 when I solve that equation. Alright, I'll go ahead and show you one more, although this would be a great time to maybe pause the video and try this on your own if you want to do that. Once again, I want to start by getting the squared part isolated. So I'm going to go ahead and add the 1 over there, and then I guess kind of at the same time I'll divide by 2, so I end up with sine squared is equal to 1/2. At this point, let's take a square root to get rid of the squared, and I'll have sine of theta equals, remember we get a plus or minus because either the positive or the negative version of this will work, which is why again I'll get an answer in any one of the 4 quadrants. And then when I square root a fraction, remember it's the square root of the top over the square root of the bottom. 2 is not a perfect square, so I'll have to go ahead and may as well just do it now and rationalize the denominator. And so I end up with the sine of theta needs to be equal to plus or minus the square root of 2 over 2. So again, looking at my trig chart to see what angle does this, I can see that the angle that has a sine ratio of square root of 2 over 2 is equal to pi over 4, which is my reference angle. And now I want to draw that in the quadrants where sine is both positive and negative. Well, again, because of how this worked out, that's any of the 4 quadrants. Okay, or I should say every of the 4 quadrants. Every single quadrant where I have a pi over 4 as a reference angle will get me a solution. So if you need to go ahead and draw the 4 different options, you can go ahead and do that. At this point, I think most people have probably figured out how to find those different angles. And so pi over 4 will be an option, as well as 3 pi over 4. Those are the 2 quadrants where sine is positive. And then where sine is negative, you could be down there in quadrant 3. Or you could be back, or all the way around here in quadrant 4. And so, of course, those 2 angles would get us 5 pi over 4 as a third solution, and then finally 7 pi over 4 as my last solution.